remind me about that. We were discussing actually the analytical functionalities and the capabilities that the T-SQL has brought with. We are able to see some easy steps to do and to follow in order to accomplish good results when talking about auditing and analysis to do. Remember that the audit is one of the contexts to avoid security issues. Disaster recovery and the forensics, they are on the basis of the audit. So it is completely a security-wise perspective. I told you last class, actually, since you did not ask, I told you that you have to come to today's class with the well understanding of what does the first value, last value do, those two functions specifically. At least you know their syntax. You do, please. Unless, even though I explained that last class. Regardless, just as per continuation to what we saw, I asked you a question in the first few minutes of this class today. What is actually the purpose behind the enhancements that the SQL brings to the math functions? And I believe that you answered. As we see, actually, this is one example that the book is presented to us, our reference is presented to us. It is one of the very good examples to understand that the enhancement has been set to, let's say, facilitate the work. This is the first view, and to encapsulate all the process once it is needed actually to be done in a segregated mode in an early age. Early versions that, for example, for the function logarithm, this is one of the math functions that it does actually area calculation and some numerical calculations. You have to know it is the logarithm. There are versions, and it's used to actually the functionality tools actually to follow some syntax in order to accomplish the result, the expected result. Nowadays, using the T-SQL, and because of the T-SQL, and starting from the 2005 actually upon the book actually, based on the book reference, we are seeing the same function that enhances two parameter based. This way actually we avoid multi inputs, because the 2 and the 11, they might be actually inputs, the 11 and the 2, 100% they might be input from the system. And since we are having two input points, so vulnerabilities to the system might be actually more wide. The attack surface is more wide. We are having two input points. So we might have two different perspectives to check, or to, let's say, two access points. They might be two rogue points. They might be actually two weak points, if they are. So to secure, we have to secure two places from where they come. But here in this context, it is a little bit actually encapsulated. It is different completely, because the input also still can be 2 points, but the process, at least, we have only one method to control. We have only one flow to control. So perspective, security talking, we are seeing actually an enhancement, yes, easy way to use, yes, let's say more clear, neat to understand. In addition to that, we are seeing an encapsulated method that does a process securely. I'll come back. I told you actually that I'm going to just discuss with you the two functions today, also the lag and the lead. Those are two analytical based. They are two methods that the T-SQL enhances. They are utilized for analysis. They provide us some analytics that we can refer to whenever needed to, let's say, evaluate, to generate an audit, to understand the process, how it has been working in the last periods, lots of time, or how it would be actually. We expect the perspectives, how we are going, it would be actually next periods, and so on. Lead and lag, they are the solution for such circumstances. Lead and lag. Starting with a lag, it is a method that reads from the previous values we are going to segregate and we are going to partition the values from columns, from fields, from let's say given, let's say, attributes, and we are going to see the current value based on the format, the prior given values from the partitions. We're going to select. We're going to do. Let me just show you the syntax of this method. Let me just show you the syntax of this method. Are you able to see the highlighted syntax, the lag? Is it visible to you, Sharifa? Shall I mark you absent, Sharifa? Mark you absent. Great. Lag syntax, how we write it. Actually, we need absolutely a return value. What is the return value? Actually, the output of this method. No worries. Yeah, okay, Sharifa. The return value, actually, what this lag would return to us. So what is the thing to be returned to us? So what it would actually display to us. The perspective view, since the lag, it reads from an old range of values from group of attributes or from an attribute. Here it is, the expression. So the offset, the step, is it the last year? Is it the last 2 years? Is it the last 3 years? Is it the last week? Is it the last 2 weeks? Is it yesterday? Is it before 2 days? And so the gap. We say actually it's an offset, the step to go. There is a default value actually to be given. It's optional. Optional. Why? Because the offset would cover all. It is the one to add. Otherwise, we are going to go with a default value, which is mainly 0. Just 1 means we're going to do a default step. We're going to compare values that we're going to display, and those values we display, they are steps before, 1 step before, 2 steps before, and so on. Steps before, when we have this offset from what? From the partitioned group of attributes, which are the, let's say, if we're talking database wise, so they are fields. So the expression here, it replaces the fields we are going to read the values from. Then an order. So this partition, it is because of the over, and we discussed last class the over. So we are going to display a value over a partition. The value here is actually, it's a math function, it's an analytical function, which is the lag. Here we might have an expression even, we might have a field, depends. And then after an order when needed, in an ascending mode or a descending mode. We might have other preferences, but this is the basic syntax for this lag. Lag in English, actually, it's a term, it's literally said lag, it's previous. Good. Let's see an example. Let's see an example for the same one only. Based on this actually given one, we are going to build an outcome, and based on this outcome, we are going to select some values. We are going to extract the month from an attribute, the net sales, which is a field also, and a lag value based on this thing, actually, based on net sales mainly. Actually, the return value is the net sales, but with an offset of 1. The lag would return the value of the net sale, but with an offset of 1. What is the offset 1? Means the previous one value. It will not give us the current value. No, it will give us the last one value. From what? From this field, the net sales. The net sales. The net sales will display values. The net sales, the mabi'at. Yes. Now, what has been happening? Now, in terms of current time. And the lag would bring us values priorly set, priorly actually defined. Here we have no actually partition, since we are going to refer immediately to the net sales without any expression, not application. We have an order, yes, by month, the date, the month. We're going to order by. It's optional also. We can omit, but let's use it. Let's admit it. The title of this log, colon, the title of the field header is previous month sales. Previous month sales. So we have 3 columns: month, net sales, previous month sales. From what? From this select query. From this select query, we would have 3 fields: month, net sales, and previous month sales. Previous month sales, it holds what? It holds what? It holds this math, this analytical process. What is the entity to extract from? It is what we defined earlier here. It is one query. We're going to extract some values, and from those values, we're going to read. So we need the month and the net sales. So the entity is the one defined earlier. Is the entity, is the table we defined earlier. Whatever. Let's see. Month, here it is. Net sales, here it is. We come back to the early view. The month, here it is. Net sales, here it is. 420937 and so on. We can find them here actually somehow, but because we are making an order, so the order is not the same. The previous month sales, it holds what? It holds one step early to the current net sales. Means if we have net sales now, the net sales is 1,000. The next sales is 2,000. Near to 1,000, nothing to be. Actually, what does it mean? Net sales, those are the current values available at each period. First month, this is it. Second month, this is it. Third month, this is it. Fourth month, this is it, and so on. Okay, starting with the first month. The net sales is this value. What is the previous value? One step before. Nothing. Before the first month is nothing. So null. Null. Second month. The outcome of the net sales is this value. This is the value, yes, truly set and periodically set and actually respectively set for the second month. 200,657. What is the net? Previous month sales. It is the same value, but one step before. It is related to the net sales, but one step before. Means for the second month, it is the value of the first month, which is 38,000. And so on. And so on. For the month 10, the current value is 3,781. What is the previous, the lag? It is one step before because of the offset. One step before, we are saying, because of the offset. So before the 10th is the 9th. So the 8,000 is the net sales, the previous net sales, and so on. Any questions, please?
No, Mr.
Great. We pass to the second analytical method, which is the lead. We're going to make another analysis using the lead now, not the lag. Yes, so the lead is our, also it's another method that we can utilize to do a perspective, to read future values now, not previous values, not like the lag. It's exactly reading values from an existing range, partition, yet from future. What does it mean? Means next month, how much it would be. Next week, how much it would be. Next tomorrow, how much it would be, and so on. Next gap, next value, next input, how much it would be. It's a future reading. It's a future reading, not like the lag, past reading. Let me show you an example. Let me explain you the syntax for this method also. You are able to see this highlight?
Yes.
Great.
Yes, Mr.
Great. The same thing, actually, the same syntax respectively to the lag. It's the same syntax. We need a return value to display, and then after we have an offset. Not if the offset is offset, so the default will take action, so it's optional, the default. It's a step to go beyond, because we are going to read the next in future value, next exactly the next step, or the next 2 steps, or next 3 steps. We have an offset to go after. If it's not mentioned, the default would be actually put in action. It's a number at the end of the day. Partition means we are going to actually evaluate this value over what, if we have any expression to formulate, or any field even to formulate. Otherwise, nothing. Also, it's optional. Yes, and then order if we need it also, because it's optional. Let's dig in the example. We'll take the same values, the same case. Okay, based on an output, we have an output. We're going to deploy the usage of the lead to make analysis. So we need the month, the net sales, and the future value, the future sales, We have an offset of 1 step. We make an order based on the month. Here, the header of the field where the lead would be actually displayed is next month's sales. From what? The extraction from what? From the value you just read here. So we use those 2 fields from this entity to do the analysis we need. The lead. Good. Let's read that. So we are displaying the month and the net sales. Yes, here they are, the month and the net sales, whatever. In the next month, the 3rd field, the value would be actually the lead of the net sales, but with 1 offset. Month number 1. The current net sales is this number, 285,617. This is the current realized. The next month holds the lead with 1 step, forward. So then the value here would be the next month, 1, so 2, which is this value. We put it here. Second month, the real net sales is this number, 312,924. The next month sales, is the lead with 1 step also. So for the month 2, it's month 3, which is this value. We put it here, and so on. Any questions? This is the very simple, basic way how we apply those 2, lead and lag. Any questions, please?
No, Doctor.
That's clear. That's perfect. And I appreciate your understanding. Let me come back to the presentation. So this way, actually, I believe that you know that there are analytical functions enhanced by the T-SQL, and there are actually enhancements to prior available methods also, not only new functions, but there are enhancements to already existing functions like the log we saw earlier, like the log. The main purpose is to either generate analysis for the purpose of auditing or any functional requirement, or even for a security perspective, like when we talk in here. So we are encapsulating the process into one node, one flow, one process, one service, rather than to be 2 or more. Like in here, we have 2 logs to process. We have only 1 log to process. So in security perspective, also there is an amelioration. Except if you have any questions, we'll go a little bit further with the context of syntax, controlling the error statements and the errors within the SQL Server. Any questions, please? I'm giving you the chance to ask. Actually, I don't want to take the attendance now, just to continue the registration of the course. Later on, I will do the attendance after the recording. The exceptions and the runtime errors, they are also supported by the SQL. The runtime errors, they are also supported by the T-SQL. They are enhanced and supported by the T-SQL. Remember that the exceptions and the runtime errors, they are not a concept of SQL management, but they are actually of programming concept. They are an OOP concept. They are data structure concept, something like that. Means it's a way of programming to control errors at runtime. What does it mean? It means if you are going, for example, to do a math process, like in here, we're going to do the calculation of a surface with an ameliorated math function, T-SQL based, T-SQL enhanced, like this one, the logarithm, and we're going to pass two values. Here I'm not gonna read 11, and I'm gonna say x and y, and the user or the computer, let's say the end user, he has to input the x and he has to input the y. Whatever he will input, it will be done. What is this log? The log actually, it makes a division. So it makes the division of the log of which is the x here in this example, and here it's dy. Good. That's perfect. Okay, so it's dynamic. More wonderful. It's dynamic. Okay, that's good. What's the problem? The problem here actually, if it's the value here, value 0. If it's 0, what is the issue if it's 0? What is the issue if it is 0? If the division is by 0, what is the issue? Can you tell me, please? So the function is enhanced, means if this one is 0. If this one, the y means here, it's 0. So what's the problem if the y is 0? What's the problem? Division by 0.
No value?
It's infinite. It's not no value. It's infinite. Actually, it's a math rule. We cannot divide by 0. We cannot divide by 0. Actually, math rule, it says that division by 0, it gives infinite. And the infinite is not a number. It's not something that you can count. It's an exception. Why? Because when we input 0, when we input a value and the value gives 0 as to utilize in the denominator, and the denominator and division equation, this is an exception. Why? Because it's not given from the program at the design or the development phase. No, it is given by the user in input. In input, when the user inputs a value, the computer would read. So the program is already running. We have to control such a behavior. We do not accept zeros in the denominator. We have to control that. To control that, we use the draw statement. So it is an exception. It's not an error. The runtime errors, they are exceptions. And the exceptions, they have to be controlled. We deny. We do not let the program get stuck. We do not let the program stop from running, whatever the program is. When a runtime error happens, he has to control. The program has to be autonomous to control the errors at the runtime. So draw statements, it's a context, the exception handling. It's a context of exception handling. This is syntax. This is syntax here. We are going to generate any, let's say, context, whatever. Here in this context we are creating, we are not doing a select. We are creating an entity, which is a table. And we have actually an exception handling to handle. We are going to declare a variable, and the variable we are giving it an initial value. The initial value here, actually, if it receives 0, it is an equation. If it is receiving 0 in the denominator, so there is a draw block to be executed. It's an exception. It's a catch block. If an issue happens while running, so there will be an exception to be launched, a catch block. So the syntax says that we are going to try the block, to try the execution. If fine, that's wonderful. Khalas, we finish everything. We go to the end of the program. We go to the end. Otherwise, if it does not finish, we execute the draw. We catch the error. We do not let the program fail. No, the program won't fail. Will not fail. But there will be a catch activity to be launched. The catch is a group of other executions, other statements to be executed when the exception happens, when the error, runtime error happens. So this catch would happen. Can you repeat what I said right now? Musab, can you repeat what I said right now about the exception? Can you please?
No.
I'm talking about this context of draw, for what we use it and when it happens. It's easy to do. It's a context actually, because behind of this thing, I'm going to just declare one statement security-wise. It's not difficult. Remember that we have next week. You have to submit your assignment and you have to present that 2 to 4 minutes. So it's not a difficult task. For the last time, the draw, it's a context of security, and it is an error control. It's an error control process. So the type of the errors that would be actually controlled here, they are runtime errors. Means they happen only at runtime. They happen only at runtime. What does mean at runtime? It means the program has been delivered to the end users. It is live. It is online. And once an error happens, user reason, means the user causes the problem. It's not the developer. It's not the software. The software is running very fine. But if the user causes the problem, the software has not to fail. I give you an example. 5 divided by 0 is an exception. Here we cannot divide by 0 because how much the number is? 5 divided by 0, how much it will give us the result? It's infinity. The number is infinity. We cannot write it. Can you write the number infinity? No, it's a symbol. It's not a number. So it's not accepted. It's not a value to measure. It's not a value to measure. Because of this, so it's an exception. Can we, for example, if I tell you, open the Facebook or open the Twitter, and comment in a post, write in 5 divided by 0. Write x equal 5 divided by 0. So the result is infinity. Will the Facebook or the Twitter fail? Will be blocked? Will stop? Will be actually having a problem? No, absolutely no. Absolutely no. Why? Because there is a context of exception handling. So the system is controlling. The system by himself is controlling. If there is such recognized error that would happen only at runtime, so the system will execute something different. He will not execute this thing. He will block this one and will execute the other block. There is a syntax we have to respect. See here, begin try and try. Begin catch and catch. So either this block try to execute. If there is a runtime error here, this one will not execute, and this one will execute. The catch will be executed. Full stop. Easy. Any comments? Continue. Great. The other and the last thing we are going to see from this unit number 2, the T-SQL enhancements, is the context of the server-side paging. Another feature that the T-SQL has provided to us to make our life easy, because remember that the T-SQL and the SQL, they are not to deal with small amounts of data. What does it mean? We are not going to create a project and we talk about database security to deal with 10 and 15 lines of code. To deal with, for example, we have 10 students or 15 students or 100 students or even 1,000 students. No, we talk about trillions of records to control, whatever, to input, to retrieve, to edit, and so on. An enormous number of data. It's a professional work. It's a professional work. Because of this, we talk about database security. Thus, the server-side paging, it's a feature that the T-SQL gives to us. It has been introduced actually as per a group of functions, which is the Rankin functions. It is the Rankin it is belonging to the context of Rankin functions, or something like that. Let me choose different color. Yes, good. Rankin functions, in the sense of it gives us a classification to group of values. Group 1, group 2, group 3, and so on. It ranks the value. But this ranks, it is a context of number of contents per page. It would be actually, for example, if I give you the example, how many students have been registered in the University of Niswa since the start and the open of the University of Niswa 2004 up to date? How many? Thousands and thousands. Are you, as a human being, capable to, let's say, read them all easily if they are all listed in just one block, just one page, or listed in two groups, each 10 students in a page? I believe, as a human being, actually, it would be actually much more easy to read them if they are 10 based students per page. So that way, actually, you can read them. The first 10 students, the second 10 students, the third 10 students. How to do that? This paging. How to do that? It is to be done actually based on different techniques, but referring to the server side actually means the SQL server. The SQL server, when we talk server side, who is the server? It's our SQL server, our database management system tool. It gives us a function ready to facilitate our life. So it would rank to us the values into groups that you can control. Server-side paging. Let's see the syntax of that. In this example, actually, we are declaring a group of variables. I'll come back to those variables here because we are going to utilize them here in this block. We have a simple select. We are going to extract some values, but everything from what? From what? Here, it's a compound. Let me maximize the view. We are extracting the totality of the values from what? From a list of whatever. Actually, it's not an entity. Start is here and is here, and we are giving it a name. We are giving it a name. The output of those values here, which are the totality, they are going to be actually listed to us based on group of values from the first value, which is actually given to us based on an equation. First value, here it is, and it's a range operator. And the last row, which is the last row, here it is. Yes, this is the one. It's also an equation to do. First row, page size. Page size is the value. First row, it is what we saw here, what we defined here. Page number, it's what we defined here. So it's a math equation that we are going to adopt. The context of the row number, the context of the row number here, we are going to means we are integrating, and we are seeing here segregated whatever it is to us actually a group of values, but we are giving it a header, and we are actually ordering the thing actually based on alphabetically last name and first name. This was not possible to be actually written before the integration of the Rankin functions using the T-SQL. So actually the entity, just here one final view, one final summary. The entity we are reading the values from is this select here. We are reading, we are extracting the first field, second field, third field, fourth field. We have four fields. The entity actually we are reading from holds field number 1, which is the row number. It's a value, it's an int. And the title, then actually 1, 2, 3, 4 elements. Actually, they have 4 fields. So we are having an entity named A that holds 4 entities. We are reading everything from. So I'm going to return this size here to the normal size. By this, actually, we come to an end in this unit number 2. Unless you have any questions, I'll stop. Actually, remember, it's not the last. Actually, in this book number 2, it's not the last because the last two actually, the sequence objects and the metadata, those are 2 concepts. It's a matter of definition only. It's just reading. The metadata, the sequence object actually is another syntax via which we serialize an output. We are serializing the output. Like here, we are given page size. Here you are serializing the output. You can see the first, the second, the third. And the metadata, actually, you are adding extra data to describe an output. Metadata, it's textual, let's say, maybe. It is 100%, but it can be something different. Mainly, what it describes the content. It's a description. It's a descriptive data to describe, let's say, an output, maybe. It's a description to an object, metadata. T-SQL enhancement, actually, this way we come to an end. Unless you have any questions, those slides, they are available to you. The book, it's your reference. Fully, it is included in your in semester. And one note, please, and one request. I did not receive your acceptance. Means you did not open the email and you did not open the calendar. I do not want to take this one as a to penalize you as a punishment for you. Please, I need you now, just immediately, right after now. I'm gonna just stop the recording. I need to receive the accept mail from you. Means you have to open the email I sent you last class, stating to you the date of the midterm, and you accept the date. I have to receive the acceptance from all of you, one, by name. Is this clear? I believe so. I'm going to stop the recording just to make the thing actually short.